What's up? What's up? It's your man, Jimmy Chan. All right, so we're talking about Venn diagrams with 3 sets. As you can see, there's A, there's B, and there is C here. All right, so we need to talk about what each region would be if we were to use the set itself and the intersect or the union of each other. Right? So for example, like this area right here, right? Region 5. Region 5 is the intersect of all 3, A, B, and C. So the way I would write that is just saying A intersect with B intersect with C. Okay? And intersect, again, is what they have in common. So where they all 3 things have in common is that region 5. So let's talk about region 2. Well, region 2, if I had to write it out in words or speak it, I would say region 2 is both A and B, right? So it's both the A and the B, right? So this is where the A and B are, but take away the C part of it, and this would be the C part of it, right? So again, it is both A and B, but not C. Okay, so let's go ahead and do that. So if I was to write this down, it would be, or in letters, it would be A intersect B, A and B, intersect, not C. So anytime you see the word and the word but, it both means to intersect. Okay? So let me do this. Copy that. All right, region 4. So region 4 is this region right here. Well, doesn't that have the intersect of A and C? And then take away the B. So this would be both A and C, but not B. So it will be A intersect C, intersect not B. Okay. Region 6. Region 6. So let's take a look. All right, so region 6 is right here. That is the intersect of B and C, but not the A. So it would be B intersect with C, intersect with not A. Okay. All right, so let's talk about region 1. If I look at region 1, right, just here, it would be this whole thing, which is A, but take away the B and the C part of it. Okay. So it's actually set A with neither B nor C. So how would I rate that? I would say A intersect not B intersect with not C. And there we go. Zone 3, region 3 is the same idea as B, but take away, but not the A part nor the C part, right? So it is, again, region 3. Yep, region 3 is the B. Take away the A and the C. Okay, so it's going to be B intersect with not A, intersect with not C. All right, and 7 would be C, take away the A and B. All right, so let's do that. It is going to be C with neither A nor B. So it's going to be C intersect with not A, intersect with not B. And there you go. Now 8, however, is this outside area. Now, it's not the universal set. It really is this outside area on here. That doesn't include the circles at all, okay? So this area here would not be A, would not be B, nor would it be C, right? So this would be, I can still use this part, except this is going to be the universal. Ooh, didn't move this enough. Oopsies. Lost the E. Neither A nor B nor C. So in that case, we don't have to write the universal intersect with everything else. We just say not A, intersect with not B, intersect with not C. And that's all we got to do, all right? So that is where everything is at. So with that being said, I'm wondering if I should do that. All right, so let's put all of this into action now. Okay, so let's do an example. And the example says that you're given this. The universal set is going to equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Region A is going to equal to 1, 2, 3, 4, 5. Region B, now you're going to see something a little different right now. Actually, you know what I should do? I should do this. I'm going to put this bracket all the way over here. All right? Region B is 1, 2, 3. There's no 4. There's no 5. There's a 6. There's no 7. But there's an 8. And there's no 9. You'll understand in just a jiffy of why I'm doing this. And then set C is going to be 1, 2, 3, 4, no 5, but a 6 and a 7. No 8, no 9. Okay? Let me see here. So what I would say to you is, as you write these out, since you're rewriting or copying anyways, write it out so that it's lined up, right? If you want to draw lines, you can, but you definitely want to try to line these up the best you can. All right, so for example, and the only reason why I would tell you to do that is because of this right here. So if I look at the ones, oh, sorry, C does not have a 1. It's 2, 3, 4, 6, and 7. There we go. All right, so if we look at this, we see that 1 is shared by A and B. So now you can either do it this way. Another thing to do is to kind of make a chart so that you can kind of put everything together if you want to. But you don't have to do that, because if you lined it up this way, you will see everything as well. Okay, so it's something to think about. So here, if I was to, obviously I see A, B, and C, so what I'm going to do is I know that it is going to be with 3 sets, right? I see that it has 3 sets, so therefore I'm going to go ahead and use all 3 sets. So I'm going to go ahead and take this 3 set thing here and put it right up here. All right. And okay, so if you look at this, 1 is shared by A and B, but not C. So it tells me that the 1 is right here in this little triangle here, right? Because there's no part of it that is in C. Now, 2 is in all 3. Well, where's all 3? That would be here, right in here, where it shares, is in common with A, the B, and the C. Right, so let's use a different color here, right? And then if I use a different color again, then the 3s are going to line up, right? And the 3 is in all 3 again. So there's 3. The 4 is right here. Line that up. And the 4 is only in A and C, but not B. A and C, but not B. So there's a 4 here. 5 is A only. 6 is B and C, but not A. 7 is only C. And 8 is only B. And 9 is in neither A nor B nor C. So 9 is out here somewhere. Okay? So that's what I would have, right? So that's only the first part. Only the first part. So in fact, I'm going to go ahead and get rid of this table since we didn't use it. What it's asking for is asking for you to find A intersect with B union with not C. Okay, so let me do this here. All right, so if that's what I have to find, first thing I'm going to do is I'm going to find what not C is. Okay, what is not C? So if you look here, what is not in this circle here? What is not in that circle? Because everything in there has a C. So what is not C? That's right. Not C is going to be 1, 5, 8, and 9. Okay? Because that is the only numbers that you see that are not in this particular circle. Okay. So let me go ahead and change that back. There we go. Now I want to find out where is B. What's B equal to? Well, B is everything in this blue circle. And you're going to see that that is going to be 1, 2, 3, 6, and 8. And if I union these two, right? If I union these two, I'm going to get, so essentially, let me do this. I'm going to get this B union C naught. So if I union these two, I'm going to get the combination of both of them together, union. So 1, 2, 3, 5, 6, 8, and 9. So any number in here has to go in there because it's a union. So everything gets jammed up there. All right? All right, so let's take a look at what A might be. Okay, so actually, let's do it. Bring that down, and erase that, and say that this is combined down here. And then the A, we can look at it as, okay, so let me go ahead and put this back to the right color. And then I want A. So this A right here, what is in A? When we look at A has 1, 2, 3, 4, and 5. So if I was to intersect these two, that will be A intersect B union of not C, right? So I gotta figure out what's in common in these two together, right? So the 1 is in common, the 2 is in common, the 3 is in common, and the 5 is in common. And those are only things that are in common, right? So that means that A intersect B union not C will give me a 1, 2, 3, and 5. And that would be my answer right there. Voila. All right. All right, on to the next example. I need another one of these. Okay, so I have an example here, and the example is letting me know that this is A, this is B, and this is C. Okay, and what it's going to give me is the cardinal number of each of the different regions. So there's 5 elements in there, there's 3 in here, there's 8 in here, there's 1 in here, 9 in here, 6 in here, and 2 in here. Okay, so again, those are based on the cardinal number in each particular region. All right. So what I want to do is figure out what I want to figure out how many elements belong to set B and set C, but not set A. So if you look at set B and set C, well, set B and set C, let's do it this way. Let me go ahead and box this part, all right? So this part right here would be this region right here. Okay, so that region right there is set B and set C. So it's so far 10 because there's 1 and a 9, so that gives me 10. And then it says, but not set A. So essentially what's going to happen is that I'm taking away set A. And this is the only region that has anything to do with this red that is connected with A. Okay, so that would go away. So what is a highlighted red that is left? That will be 9. So that's how many elements belong to set B and set C, but not set A. Okey doke. All right, next one. What I'm gonna need is some movement here. You know what? Let's just let's do another example here. All right. Let me also make all this the same color. Boom. Oh, that's not what I wanted. There we go. That's better. Okay. So let's say this. Let's say that we're given this. However, we're going to be given cardinal numbers of certain things. For example, we're going to be given that the cardinal number for the universal set is 44. That the cardinal number for set A is equal to 22. The cardinal number for set B is also 22. The cardinal number for set C is equal to 18. And of course, you might be looking at these numbers and you're like, wait a minute, if I add these numbers together, it's going to go way past 44. And the reason why you think that is because you forget about the crossovers, right? The duplicates that you're actually counting. So we got to be careful with that as we're going, all right? So let's keep on going. The cardinal number of A intersect B is equal to 11. The cardinal number of A intersects C is 10. And the cardinal number of B intersect C is 9. Okay. So what I want to do is I want to find the cardinal number for each region. However, you are given this as well, that region 5 has 7. The cardinal number is 7, so there's 7 elements in region 5. Okay, so yes, so they're talking about sets, they're talking about regions, so they're kind of combining everything together. All right. Okay, so let's look at this. The best way to do this is start small and inside, and then get bigger and towards the outside. So it's best to know 5 first, then get 2, 4, and 6, then get the 1, 3, 7, then the 8. Okay, so we gotta work in that way. But since the purple is already done, do you want to do the red, yellow, or the green? Great, let's stay with the numerical orders, right? So 2 comes before 4 and 6, so let's do 2 first. Okay, so 2, so if you look at 2, that, I should put it this way, how about this? 2 and 5 together is the intersect of B and of A. So here's A and here's B, and that's where this intersects, right? Of A and B. So that is going to be so I'm just painting in the 2 colors that you're going to see side by side. Okay, so the purple and yellow, the purple and red is going to have 11. Okay, so if the purple red, so if this right here has 11 and this has 7, how many does this have? Well, if the whole thing is 11 and part of it is already 7, wouldn't the rest of it just be 4? Right? So that part's going to be 4. All right. So let's take a look at this 4 here. All right. So if I look at this 4 region, I can see, again, same thing, this thing right here, which is the intersect of A and C, which is region 4 and 5. So that's the intersect of A and C, which I see. So I know that this right here has purple and has orange. There we go. So that right there is 10. So if you look at it, this purple and yellow region has 10. So 7's already taken up here. So how many do I still have? I have a 3 left. Okay. And then let's look at this region right here that we haven't dealt with. So what is that region? That region is where B intersects C, but it takes care of region 5 and 6. Okay, so let me go ahead and do this. And green. Okay, so that right there that right there has 9. So the purple and green has 9. And 7's already taken up. So how many do I have left? I have 2 left. Okay. All right. So I at least have those regions already taken care of. So I got 2, 4, 5, and 6 done. So I just need the 1, 3, 7, and 8. Okay. So let's take a look at this circle right here. Let's call it red. So that circle right there has 22. Because this says right here that the cardinal number of set A is 22. Well, if this whole red circle is 22, this part here takes up 4, takes up 7, takes up 3. So these 3 part right here takes up 14, right, of the 22. Of the 22. So how many is left if you take 14 away from 22? That would be just 8 left. Okay. Okay. Let's take a look at set B. Set B says that it also has 22. So this blue circle has 22. But it's the blue circle that has 22. Well, 2, 5, and 6 take up 11, 12, and 13 of those 22. So what you have left in region 3 is just 9. And if I take a look at region C, in green, that has 18. So everything in the green circle is 18, but 2, 7, and 3 are taken up, which is 12 of those 18. So all I should have left is going to be 6. All right? So now, last but not least, I have to find region 8. Well, the universal set, meaning this whole purple box that I just highlighted, the purple box itself, that means everything in here should have 44. Okay, so the purple box has 44. Okay, so the purple box has 44. What is left over out here in those regions, right? So you would take away the 8, take away the 4, take away the 9, take away the 2, take away the 7, take away the 3, take away the 6, and whatever's left over is what you have left, which is going to be 5. All right, so there we go for that example. All right, so next example is going to be this. It's going to say, it's going to be a word problem. It's going to be a surveying problem. So what it says was that there are 76 students, college students, that responded. 34 of them get their news from the newspaper. And 24 of them gets their news from the television. So, and 8 of them get their news from both the newspaper and the television. Okay? So I need to draw a Venn diagram. The question is how many sets are in here? And if you look at this, this is the total number of students. They were talking about how do you get your news. You get your news via newspaper, TV, newspaper, and TV. There's no other sources besides these 2, so you really only have 2 sets. So let's go ahead and just draw it. Why not? So here we go. Wasn't trying to bring that around. All right, there we go. This. Okay. All right, so it says 76 students. So we need to call one of these circles newspaper and one of these TV. All right. So again, when we label these, always inside out. So what I see here is that this is telling me that 8 of them read the newspaper and watches the TV. So the 8 will go right in here. All right. So if 34 read the newspaper, how many people read the newspaper only? Right? So again, this circle right here represents everybody that reads the newspaper. So this whole thing in blue is the 34, but there's already 8 taken up. So I really have 26. Similarly, oops, I didn't make this blue. There we go. Similarly with the TV, this whole circle, this whole purple circle, takes up 24 of them, but 8 of them are already taken care of. So how many do I have there? I should have 16 left, because 16 plus 8 is equal to 24. Okay. So what we have is that with these numbers, you can see that we have 26 people that do newspaper. Ooh. Only. That's what that 26 means. We have 8 that do both. We already know that. And we got 16 that do TV only. All right. Now, I want to know the number of people that do either one or the other. So it does the newspaper or TV. Well, that would be the people who do one, the other, or both. So you would add up all 3 numbers, which is the 26 plus the 8 plus the 16, and you'll get 50. Okay? So how many people would do neither? Neither means neither one nor the other, so essentially they would be the people who would be out here, right? Not inside any of the circles, just out there, that don't look at the newspaper, don't look at the TV, okay? So that you would then take the 50, right, which is everything that's in here, if you subtract that from what it started with, then you'll know who else is remaining. Okay? All right. So, question is, how many do neither? Try to find a place for this. So again, how many people do neither the newspaper nor TV? Well, that you would take the number of students that was surveyed minus what was inside. So that's going to be 26. So 26 would be out here. All right. Well, that's the end of the notes. I wanted to make sure that I keep some of those practices to you. Hopefully it helped. If you have any questions, please let me know. Talk to you later. See ya. Bye.